I'm Uduak Aleton, your facilitator for Bio 216, Chemistry of Carbohydrates, Lipids, and Nucleic Acids. In this lesson, we'll look at the classification of lipids. Listen attentively and learn. Thank you. So, this is T Bio 216, Chemistry of Carbohydrates, Lipids, and Nucleic Acids. I'm Uduak Aleton. We are looking at Module 2, Unit 2, Classification of Lipids. We spoke about fatty acids in our last video. So, classification of lipids. At the end of this lesson, you should be able to classify lipids and then discuss the various classes of lipids. Can be classified into two major groups. They are either saponifiable or non-saponifiable. And what do we mean by saponifiable? When a lipid can be hydrolyzed with an alkali to form soap as one of the products, they say that that lipid is a saponifiable lipid. But if a lipid does not undergo this reaction, you say it's a non-saponifiable lipid. Among the saponifiable, the acylglycerol, the phosphoacylglycerol, the sphingolipids, and the waxes. Whereas for the non-saponifiable lipids, we have the terpenes, the steroids, the prostaglandin, and other related compounds. Acylglycerols, also known as glycerides, what are they? They are the most abundant and widespread lipids. They are the ones you find when you buy meat and you say the meat contains fat. It is the acylglycerol that is deposited in that fat you are seeing. So, and this acylglycerol have glycerol as their backbone. And depending on the number of the OH esterified to fatty acid, they can either be mono, di, or tri. If only one of the OH groups of the glycerol is esterified, you have the monoacylglycerol. If there are two, you have diacylglycerol. Or if three of the glycerides, if three of the OH groups of glycerol have been esterified by fatty acids, you now say you have triacylglycerol. And then apart from that, they can also be hydrolyzed by lipases. Lipases are enzymes to form strong alkali to form glycerol and the fatty acids they contain. And another thing you have to know is that the fatty acids may be the same or different. They can be three different fatty acids in the esterified to the acylglycerol, or you can just have the same. So it can either be, for this one now, I have three different fatty acids, but they can just be one fatty acid, the same fatty acid in each of them. The next group are the phosphoacylglycerol. From the name you can see we still have the acylglycerol, but this time there's a phosphate group attached to the one of the positions of the OH groups. When this phosphate group is attached to, and then we have two fatty acids still attached to the glycerol, it is called phosphatidic acid. However, the phosphate, the one of the O in the phosphate, can still be esterified by ethanolamine or choline. When it is esterified by ethanolamine, you have phosphatidyl ethanolamine. If it's by choline, you have phosphatidyl choline. This can also be called lecithin or cephalin. So here you can see that we have esterification in many places. First of all, the OH of glycerol has been esterified to esterified with fatty acids. Then one of them was esterified with phosphoric acid. Then the OH or the O of this phosphoric acid has also been esterified. When this when this occurs, you now have what we call phosphatidyl ethanolamine or phosphatidyl choline, depending on what is esterified. These are major components of the cell membrane. So apart from that, we have the sphingolipids. What is so special about sphingolipids? Instead of having the glycerol we had before as the backbone, we have another compound. This compound is a long chain amino alcohol known as sphingosine. So, and it also has a polar alcohol end. When this sphingosine occurs in the place of glycerol, you say we have a sphingolipid. And just like we have different types of acyl glycerols, we also have different types of sphingolipids. A sphingomyelin, when you have the sphingosine attached to a fatty acid at position 2, phosphate also esterified by choline. This is called sphingomyelin. Sphingomyelin is found in nerve cells. It helps to protect the axon. And this also helps to protect you and I. If this axon were not covered by this lipid, we'll be having electric shocks as our nerve impulses are being transmitted. But now it protects us. So apart from the sphingomyelin, we also have glycosphingolipids. Glycosphingolipids, still a sphingolipid, but it does not contain phosphate. Rather, it contains a sugar unit attached to the position 1 of the sphingosine backbone. We still have fatty acid on position 2. So this is called glyco because it is sugar that is attached. There are different types of sugar that can be attached to the glycosphingolipid to form different types of glycosphingolipids. For example, we have cerebroside, we have globoside, depending on the sugar attached to it. And apart from this, we can also have another group of sphingolipids called gangliosides. Gangliosides are still glycosphingolipids. In other words, they are sphingolipids that still have a sugar moiety attached, then with another compound called nana or sialic acid. Sialic acid. So when sialic acid is attached to a glycosphingolipid, we have ganglioside. Ganglioside is very, very necessary in the brain. Then the last type of saponifiable lipid we have on our list are called waxes. Waxes are just what they are. You can see candle wax. You can remove some wax from your ear, Also beeswax. What do they contain? They are esters of long chain fatty acids with long chain monohydric alcohols. When fatty acids combine with alcohol, they form waxes. The one we have here is fatty acid having how many carbons? 18 carbon. You can see it's 16 plus 1 plus 2, 18 carbon atoms combining with this alcohol that has 30 carbon atoms to form beeswax. So and what is so special about waxes? They are highly insoluble in water and they are chemically inert. That means they are not reactive. They are chemically inert, and of course, they contain long chain fatty acids or long chain monohydric alcohols. So let's pause for some refreshing time. Which of these statements is not true of waxes? Which of these statements is not true of waxes? This is a class activity you can do. I'll give you just 3 seconds to, okay, let me make it 5 seconds to look at the options and answer the question. Good. So that takes us to the second class of lipids, which are the non-saponifiable lipids. They do not form soap when reacted with alkali. Examples are steroids. This structure we have here is the steroid nucleus. Every steroid you have is formed based on this structure. It can have CH3 or methyl groups attached at position 10 and 13 or whatever it is. With any modification in this structure, it is converted from one type of steroid to another. But the most important thing is to note that this is where it all begins. Now, when the steroid nucleus has one or more OH group, for example, we have an OH coming out from position 3, it is no longer called a steroid, it is now called sterol. And that is where we form our cholesterol. You can see cholesterol from this sterol. Cholesterol, let's look at the structure of cholesterol. Okay, this is the structure of sterols. You see, you can see this is still the steroid nucleus, but it has an OH coming out from somewhere. And this is our cholesterol. You can see the OH coming out with other attachments. You see other methyl groups, hydrocarbon, see it. So this is the structure of cholesterol. You can see they are still from the basic steroid nucleus. The next group of non-saponifiable lipids, that's lipids that cannot be used to form soap, are the terpenes. Terpenes are hydrocarbons found in plants, and they are composed of isoprene units, 2 or more isoprene units. This is an isoprene unit. You see there are 5 carbon atoms in one isoprene unit. So if we have 2 isoprene units, we have 10 carbon atoms. If we have 3 isoprene units, we have 15 carbon atoms. But the most important thing is that terpenes are formed from isoprene units. So let's take a break and see if we can get some questions answered. Lecithin, phosphatidyl ethanolamine, phosphatidyl inositol are all examples of derivatives of L-glycerol 3-phosphates known as, go back to the slide and see if you can answer this question. Good, correct. So what's the answer? Fine. If you are not sure, just go back to the slide and answer. So this brings us to the end of this lesson. And what have we learned? That lipids can be classified based on the ability to undergo alkaline hydrolysis into two major groups, saponifiable and non-saponifiable lipids. Thank you.